Thanks, everyone. Welcome back. Good to see you. I'm John Ball, the CTO of Padding. And today I just want to go through the supplementary video that really finishes off what we started last time. What we're doing is talking about the new NLU industry. And there were a couple of things that didn't quite come off. We had a problem with our YouTube videos while we were broadcasting. So let's have a look at that, and let's just go through some of the key points at a reasonably relaxed rate. So let's get on with it. So the first thing is, let's go and have a look at that dialogue video again. It runs for about 3.5 minutes. Let's see how we go with describing what's going on. Let's make that a bit bigger. Okay. So what we see here is, on this side, we've got the information that we receive. We break it down by meaning. I'll just hit stop there. And if the information that comes in is just a statement, we're going to store that in context. If it's a question, we're going to look at what's in context and deal with that next. So here we've got some new context that's gone in. We're then going to pass the details to the generator, which just gives some sort of trivial response to say, yes, we've recognized that we had something there, something new. Mary journeyed to the bathroom, another piece of information. And now we get our first question. So I'm going to introduce the concept of intersection. When we have a question, what we're going to do is simply align all of the elements that match. So John is then the actor position. We've got a where location, which in this case is a goal, a destination. And so because John matches with the question, we're going to put into our intermediate workspace the fact that John, whatever that information was. And then we're going to extract to the hallway, which is where John is. At the end of that, John went to the hallway, John is in the hallway by definition. And so we're going to select the appropriate preposition, in the hallway, not at the hallway or on the hallway or over the hallway. We have to understand what it meant in the first place. And then we get a response from the generator. Now this could be in whatever language that you've set as your output. In this case, we're just using English to English because let's not make it too hard. So now we're going to add some more context. So again, every statement that goes in is adding context. Every question interrogates context at that point in time in order to determine an answer. So let's see, John's moving to the bedroom. Response, yes. Again, whatever the responses are just kind of trivial. I get it. Okay, where is Mary? Intersect Mary as the actor. She went to the bathroom, generate to the bathroom to an answer in the bathroom, or Mary is in the bathroom. As you can see, it's not a complex processing problem here. We're simply matching and using the results. Okay, hopefully by the end of this, you'll be able to see some more complexity being added. So we've got Sandra, John, Daniel, and Mary. Where is Sandra? We'll intersect Sandra. She's in the kitchen. So to the kitchen plus position is in the kitchen. She is in the kitchen. Sandra's in the kitchen. Now Sandra's moved. If you ask the same question again, you hope she's now in the hallway. And she will be, because we're simply tracking the sequence of these events. John went to the garden. Sure. Okay. Okay, let's just pause it there. Here's what the system's saying.
At this point, we've intersected and we found it. Two Sandras. So those two Sandras come across here. Now the question is, where is Sandra? So we're going to give the current position, and the current position is always the last thing that we've received. And it could be more complicated than that. We could have had past tense, future tense modals. But this is how that's working.
So what do we see? Hopefully in the hallway, or she is in the hallway. So the same process works. It's just very simple. You're choosing something off the list. And in pattern theory, the constituents are sets or lists. So it fits very nicely with this type of conversational model. Finally, she's moving to the kitchen. You can see the complexity if we ask where is John or where was John. And it sounds complex. It's pretty simple. You get your list and you produce the appropriate elements from it. Now, where is Sandra? We've got a whole bunch in the list. So we're going to choose the last one because it was where is Sandra. She moved to the kitchen after those other things. So is this a complex system? I don't think so. Okay, so we'll finish up on that one. Okay. So the next thing we can look at is the enterprises with enterprises of government. You know, who should run the NLU systems of the future? So here we've got a bunch of enterprises. We've got a dictionary that's built for all of the world's languages. And on this side, we have a bunch of specific languages. And each one of these is going to be managed specifically for those languages. So we should be able to separate out these pieces. At this stage, the plan is, it's just around enterprises versus government. The goal is for the institutions to produce their own content, and they can then check that the output is appropriate for the consumers in the language that they're supporting. So if it's the New York Times, they might initially check English. They might also check Spanish for the output. And through that type of continuous checking method, over time, there should be no checking to be done because all of the results are going to continue to be consistent and they'll know the tricks to make sure that it does. In the middle here, we've got the dictionary, the meaning of the words in the language, and that's going to be somewhat decomposed. But on the left-hand side, for example, English, Spanish, Korean, Mandarin, that's what my company, Pat Inc., is working on through this year. We're focused on English, and we're hoping to get to a couple of these other languages before the end of the year. So that's building the dictionary content. And then there's a bunch of other languages, which obviously over time you could just keep producing for that. In some cases, there won't be many users. You know, maybe in Sweden, I think there's like 10 million people. Maybe to do Swedish would be something which the government would create and manage, or an enterprise in Sweden might take responsibility for it. There's a lot of options there. And at the moment, Pat is working on the dictionary source, and each element, each word in the dictionary is addressable both by the language, so it could have a language-based definition so that the people working on the dictionary know what it means in their language, and it'll have a label, which again could be, it's not used in the system, but it can be used by the specific language definition for review. Okay, so let's move on from the, let me just clear that there. We'll just move on from the industry to a bit more detail about how the mapping goes from the words of the language to their definitions. And we talked about the fact that there's a difference between indexes, like pronouns. So when you say he, you're referring to a single thing that's male, as opposed to they, which be a group of males or males and females or just females. So it's not referring to a single thing, it's indexing to this category of things. So that's got to be handled differently in context, because that's how we work it out. Take a different category. So here's a predicate, the word eat, which is a consumption activity. So it's a symbol in that eat just means arbitrary, through convention. It's this concept of biting, chewing, swallowing, maybe digesting as part of eating. The point is that eat can have a number of meanings associated with it, and I'll get into a bit more detail how that works. A referent is a thing, and for example, dog is a kind of animal, it's a category. And these predicates and these types of reference are really the basis of language, along with the indexes. If you have those three in pretty good order, you can get around. You would sound like you had some sort of aphasia because you're not naming things properly, but you're still able to say, I want to go there or to this building that has whatever, it's a 100-story building, Empire State Building, however big that is. And then this last category are specific reference. So companies, people, places, there's an extremely large number of those, all with their own unique names. Well, sometimes they're unique, sometimes they're the same. And you have to work out in context what something's being referred to. So those are the main categories that we have to work with. So let's have a look at how now the word vector model, which is the one, let me just take that off for a sec. The word vector model works, that is the basis for deep learning and machine learning techniques at the moment. So here we've got the word king. So this is the WordNet browser. I'm just taking some examples so you can get a feel for it. You've got king as a male sovereign, that's a definition. A king or a queen can also be the preeminent position. What else have we got? In chess, it's a piece. In checkers, it's a piece. It can be one of the playing cards. So there's a few different things, and plus it can then be somebody's surname. So in order for NLU to work, we have to be able to work out in context what's what. So here's one of the goals of the semantics team at PAT, or the semantics team for NLU systems, if you're working off the role and reference grammar model. So when you see the word king, we saw from the previous definition, it's a person, they're male, and they're the sovereign, so they're the head of state. It's the top of some category of people. The second definition, it says a preeminent position. So again, it's the top position of some sort of person. In the case of a baron or king, it's the leader, it's the top person again. If king is an animal, so king of the beasts, it's the top position of the beasts. So where top is appearing a bit here as part of the definition for king. It's not the only definition. We've also got whether it's a person, an animal, if it's a name, is it a checker piece, in which case it have a different meaning. So if you can work out what the thing is that you're referring to, then you can store that with accuracy because it's a different sense. And as a result, you can then generate it back into another language. Because if the word for king in English, when you're referring to the monarch, is a different name to king, which is a chess piece, as long as you know that it's the chess piece versus the monarch in English, then when you're trying to generate it into another language that might have a different name for the king in chess and the king as the monarch, the system will still work. Let's have a look at a different one. This is a very popular example, the use of the word bank. And I'm highlighting here in blue where bank is referring to the company. And companies are complicated because they can have a number of buildings. They can have people who work for them. They can be in multiple countries. It's a complex concept. So the first definition here is talking about the financial institution. The second definition down here, it's talking about a place to keep money. So the coin bank was empty. It's a place where money is stored. Well, that's what a bank building is doing. Banks are a place to store your money. And you can also use it here as a predicate, as a verb in the syntactic concept. Where do you bank in this town? You're talking about where is your bank's buildings. So that's one of the concepts of bank. The other one here, which is in red, is bank can be sloping land. So the water that the bank is the land that slopes into the water. So that's a river bank. Down here we've got, if you have a slope in a track, you've got the track banked, you've got the road being banked. So it's the same concept, the bank of a river or a banking road. And we can have down here as a predicate the idea of a plane banking, where the plane turns at an angle as well. So again, the goal of a semanticist here would be to say, what does it really mean? And if it simply means either slope or the concept of an institution, great, identify that. And an institution can have branches and people and other things. As I'm showing at the bottom here, an angled or tipped thing or institution, maybe that's all of these definitions for bank. Maybe it's not quite there, but that's the goal for semanticists. So this is the summary. So the bank can be the financial institution that holds deposits. It can be a building. And one of James Pustiovsky's concepts, he's a computer scientist at Brandeis, he pointed out in the 90s that this concept of qualia applies where if you've got a referent, he says noun, if you've got a referent, you can then work out what it's for. There's a whole bunch of properties that these have, and we look at it in the same way that predicates determine arguments, so the arguments can therefore have access to the types of predicates that they connect to. And also bank is a supply held in reserve. So it's sort of looking like there's a consistent definition underneath all of this. Also, it's sloping land beside a body of water and tipping laterally of a plane. So there's a couple of definitions there, and our approach would be to try and simplify it as much as possible, but don't make it too simple so we're losing the meaning. Again, the semanticist's job is to simplify that. The CEO of PAD often talks about orange. You've got to be able to disambiguate orange. So are you talking about a piece of fruit? Or in this case, in WordNet, it talks about that's an orange referring to the tree. I don't think in context that makes sense. In discourse pragmatics, you wouldn't say that's an orange and people would think of tree. They think of fruit. You'd have to say that's an orange tree, or you see that tree, it's an orange. And at that point, you've provided enough context to determine what it is. And then we've got orange, orangeness, a pigment producing the orange color. And then you've got names like the Orange River. We've also got adjectives here, a color between red and yellow. But that concept of the adjective is also the predicate, the orangeness. It's interesting even looking at this, determining is it a predicate or a referent. The rule of thumb here is that if it's a verb or an adjective, it's predicate, because fundamentally it's providing some association to its arguments. So if something is orange, you can say, well, orangeness is a thing. Well, it's not. Orangeness is something. It's a possession of something. That fruit has orangeness. You can't just say orangeness and expect somebody to know what you're talking about. Okay, let's just go through a bit more of how we build up the knowledge representation, because in RRG you've got syntax linking to semantics in context, and we want the representation of that to be lossless. There's semantic networks where you can simply connect a few things. I'll show an example of that, I think. But here, what we want to do is take the synonyms like Alan Matheson Turing, Dr. Alan Turing, Dr. Turing, Alan Turing, Alan. All of those are synonyms for some referent, and the reference obviously complex. When you learn about people, you're learning a lot of different facts about that person. So we have these associations that we're going to rely on. But on the meaning side, you can simply draw that's Alan Turing, this X that I'm pointing to. And then we can add hypernyms like X is another X, which then links back to the fact that he's a type of person. So this is a specific, what we call specific, and this is general. These are the things, the specific reference in the world are the very large numbers of things that make language hard to recognize unless you've got your list. It's named entity recognition and in some circles. But person is part of the language, and if you want to get by in English and you don't know what a person is, it's probably going to be difficult. So there's an example of a person, and the very, very first step to identify that these labels go to a person. Over here, we're going to look at the Big Apple, New York, NY, and those are your signs. Again, the signs are the things that are arbitrary, that are connecting to the meaningful elements. And in here, you've got X's that are being a bit more fleshed out now. So New York has, what have we got? It has a government has staff. One of the staff is the governor. You can see that you can very quickly build a network which has to, all of those elements of the network has to trace back to New York. It's got to be context, not semantics. You can't have the governor of New York and say, well, the city has a governor, and then not know that a particular governor belongs to New York, and it has to be tracked in time, because all of these things in the RRG layered model, you track in time and space with reason. Okay, so when we talk about context, this is from one of my Medium articles. I'll provide a free link in the at the end of the YouTube video. You can see that when you're talking about context, immediate common ground is probably the right term to use, or context of utterance, or context of situation, depending on which semanticist or linguist you're talking to. But notice in the immediate common ground, we're storing things like the specific reference. We're tracking the I, you, he, she, it type pronouns. The possession, obviously possession is just another way of identifying people and their associations. Who's attending, so who's hearing what you're saying? You know, when you're in a meeting at work or at school and somebody talks to you about, you know, they've done this and that, and a new person walks into the room, you often find the person speaking will repeat everything because they know that person wouldn't know what you're talking about otherwise. And that's because our brain is very good at tracking the context of the situation, the context of utterance. We're tracking, let's see, what else? Locations, where are you? When did this happen? We have some good tricks in English. Well, in all of the world's languages, you've got tense aspect and modality that help us with future, probable, past things that have happened. So all of that is part of the context of utterance, and we want to store that in a lossless format, that these particular facts, these elements of context took place, and these are the people that knew about it in these locations. So not because we want to do it this way, but when people are operating, this is the type of information we have to hand, and it's named by linguists. Once you've got this immediate common ground stored, if you persist that in long term, it's now in a lossless format that you can bring back later and interrogate, or you can use to answer questions in the future about something that took place during that meeting. And that's the concept that we're working on for, say, the New York Times publishing articles in a meaningful, lossless manner. That this context of utterance will be identifying the articles, the date of the publication, the byline, etc. And as a result, we've got a much more accurate system than a text-based one, because now when you search on it, you're searching based on the meaning. And when you're inquiring what you found, you're now working with the meaning, so you can generate it into any target language you like. And this is what I was mentioning before, that when we look at language, it's not as complicated as people have made it out to be, where you've got to cover every book ever written in order to start to manipulate the language. There's really two things that you want. We want the general predicates and reference. So, just to summarize again, if I haven't written it down here, we've got verbs, adjectives, some adverbs, when and where. So how, when, and where, I guess, is the way I like to put that. Prepositions as well. A lot of syntactic elements are predicates, and then we've got general reference like categories of things. And predicates often take nominal form, so they look like reference, but we're still tracking them as predicates. And then at the top, we've got the specifics. So the names of people, companies, addresses, streets, suburbs, phone numbers, product names, it's all sitting in that specific area. So what we want to do is move the immediate common ground to the general common ground. Then we've got our unambiguous background knowledge that we can store forever. And the reason I said in the last stream that we want to be able to access this in 1,000 years is if we build these meaning-based systems, it doesn't matter what the language is that's popular in 1,000 years, you'll still be able to access the meaning and extract it for your language, because the language is now being split from the representation in context. Okay, so what's wrong with the semantic networks we have today? Because it's a very big part. It's been a big focus of the corporate world. And I'm not going to use a database-like model. Let's just have a look at this one that comes, let's see, from a semantic network in Wikipedia. So this one on the left here, you can see that the knowledge graph has a mammal, it's an animal, fish is an animal, fish lives in water, whales live in water, whale is a mammal. So this is like a database, because we're simply taking a word and we're giving it an association. In the case of storing this as context, so mammals are always animals. That's its definition, and bears are always mammals. But here we've got bear has fur, and okay, that's usually true. But what if you see something that's a bear that doesn't have fur? Is it not a bear anymore? So we need to be able to deal with the fact that most people have hair, but some people don't, and yet they're still people. But you want to be able to store these associations. And the way to do it is, rather than think of these networks as being semantics, they're built of semantics because they're generalizing from real world experience. Think of it as a context network where in context, all the facts are accurate, or as accurate as any facts or opinions can be. But underneath that context, you have these associations which generalize. So most bears have fur, not because we have to memorize logic, but because you know of a bear and that bear has fur. So at this point, you can say some bears have fur. And if you see lots and lots of bears, and all of those bears you've seen have fur, all of the associations between those particular bears you've experienced are also associated with fur. And as a result, the ones that don't have fur are still bears. And now you can say some bears don't have fur. You know, I'm certainly in the case of cats, there's cats that don't have fur, from what I've seen. So that's our way of getting around the lossy nature of it. And if you were to use this in a sentence, you could say mammals are animals. But there's some cases where there's things that aren't currently animals anymore. So dodos, I think, are an extinct bird. So you could say dodo was a mammal. I don't know if you'd say it is a mammal still. You can imagine when you start to use language properly, though, use these things in a sentence, you're going to find that some of these associations, there is a relationship, is okay semantically, but it's not the right one for that particular sentence. You need to record the specifics of what we're saying. You know, so if you say dodos will be birds again, you know, because they're not birds now, that's a future modality, future tense concept. So that's how things become lossless. You simply use the things we know in linguistics that have to be obeyed. And here's the super knowledge graph model. So you've got the context details. So who's involved in this conversation, who's seen it. That's the key part of the context of utterance. And then we have this semantic representation. The role and reference grammar one is the one that I use because it works across the world's languages. And that is going to have an association to the dictionary definition that applies for that particular representation. And we've worked through with people to take that semantic representation and persist it in a knowledge graph with the additional information here. Okay, I think this is the last topic that we only touched on, which was the cybernetics model looks at these feedback loops where you start with we'll start with the processing model. So in AI, we usually talk about process. So you've got your inputs, you do some sort of processing, and you generate outputs. In the case of pattern theory, it's pretty clear that, and I guess if you look at the anatomy of a brain, it's very clear, is that brain regions connect to other brain regions in a bidirectional manner. Maybe not all brain regions, but certainly the cortex, which is where our language is coming from, human language at least. So if you've got these forward and backwards projections, it's not really a input process output model. It's more of a input, recognize something, project forward what you've matched, see what you recognize there, project back things that made sense higher above based on those elements. And you can use that system of top-down, bottom-up analysis to get a much more accurate and quick response with a particularly slow brain when you compare it to a computer. And cybernetics is along that line of you're receiving your inputs from your sensors, you're doing something, and then you're controlling through some sort of motion control, and then you're observing the effect of that motion control. It's a little bit deviant from the pattern theory model and the brain model, but that's okay. It's closer to pattern theory than this input process output model is. And this was an example I found on Quora, where Amir Mamagani had these examples in his response. So I think it's worth having a look at in Quora. And in order for this driverless car image to be processed, we're seeing image acquisition, pre-processing, feature extraction. This is showing a one-directional flow. I'm presuming that's correct. There's no reverse links. And then there's a bunch of steps taking place at each of those. And the end result is it's tracking these different elements. My argument here would be that biology does a pretty good job at these things, and dogs and cats have good vision, as do people, and perhaps some of the reverse bidirectional associations would be more effective at solving the unsolved problems with driverless cars. And like I see here in pre-processing, things like contrast enhancement. So the eye actually does a level of enhancement by dilating the pupil or contracting the pupil, changing our focal length by squeezing the eyeball. There's a bunch of things that perhaps would also help us to recognize these things in a human-like way, because this one of the limitations of writing code in good old-fashioned AI is that you write a lot of code and then you're maintaining a lot of code. And once you start to write millions of lines of code, if you don't have your levels right because you've got no hierarchy, it gets pretty complex and it's hard to manage. So that's the references. I'll include those with the other posting that we do with the video, so you can actually look at the sources that I've included here. So thank you very much. I did want to go out on a note, so let's check this out.
Oh, that's the orange robot. That's not what I want to do.
I want to go out with this one. Thank you. Oh, look at that. The audience is back. Thank you very much. Okay, guys. See you next time. Bye.